Hello everyone, my name is Rich Nowakowski from Texas Instruments, and welcome to TI Analog eLab. Designing a power supply for a performance processor is a pretty challenging task, especially because process nodes for these processors keep shrinking. So we have to consider some power supply techniques that are really good design practices. And today we're going to talk about some of the techniques that we use for the Spartan3A development board. And I have some guests with me today that I'd like to introduce you to. First, we have Brian Fletcher from Avnet. Welcome.
Thank you. And
also joining me today is Jamil Hussain from Xilinx.
That's right. Great to be here.
Thank you, guys. Welcome. Thank you for being here for TI TV. Well, the first thing we want to talk about is the Spartan3A development board. So, Brian, can you tell us a little bit about that board and what the scope of that board was?
Sure. In early 2008, Avnet decided that we wanted to design a very low-cost FPGA development board. Being low cost was the key objective for that board. We also wanted to highlight the ability to power an FPGA development board from a USB port on a PC. And then we also had in mind a few key peripherals and memories that we wanted to interface to the FPGA. And with those objectives in mind, we decided that the best FPGA for our low-cost evaluation board would be the Spartan3A FPGA from Xilinx.
Okay, cool. Thank you. Jamil, can you tell us a little bit about the applications that the Spartan3A would fit into, and a little bit about how it fits into the Xilinx portfolio?
Yeah, sure. Well, the device that Avnet used was the 400A, which has 400,000 logic gates, right? So this is like a mid-range to lower-end FPGA in the Spartan lineup. Now, the Spartan lineup, the extended Spartan3A family, has devices that range from 50,000 to all the way to 3.4 million gates. So this 400A was really a great device for these ultra cost-sensitive applications. So the Spartan3A family has a number of features and options that really make it very appealing to consumer markets, networking, wireless, wired communications. I mean, you name it. The extended Spartan3A family is really targeted for these high volume and low cost applications.
Oh, very good. Brian, I remember you saying that the development of this board was really a joint effort. Can you go into a little bit of detail as how that was done?
Obviously, we partnered with Xilinx since we were using their FPGA, and we had some other partners for the peripherals and memories. But knowing that having a functional low-cost board was a key objective for us, we also partnered with Texas Instruments to design the power supply for this board. We knew that Texas Instruments had some great options that were very efficient, would be low cost, very small for our board. And so knowing that the power for this board would be critical, we asked for Texas Instruments' help to make sure we designed the ideal solution for this board.
Oh, thank you, and we're very glad to help. Some of the things we want to also talk about in this video is running through the whole design process. Not only the part selection, but we also want to look at some of the intricacies of the FPGA and see how well we can power that with some of our parts. Other things that we want to do is after we choose our part and design the power supply, and we'll look at some of those considerations, we'll also look at some examples of how we debug the power supply and validate it to make sure that it works properly. And there's some tools and techniques that we'll be going through towards the other presentations in this series. But the next thing I want to talk about as far as designing the power supply is what to consider. First, we have to consider the input voltage and the output voltage. And that's very, very basic requirements. But more importantly, we need to consider the output current. And we'll be talking about how we estimate this current a little bit. Also, another thing to consider about a power supply is the special features that are going to be needed. Like some things we'll be talking about are the startup performance, transient response, for example, the voltage regulation accuracy. All of these types of parameters are very important in designing the power supply. For example, when we're considering how much ripple we can tolerate in the system. Also, we have to consider our input source. Are we powering from a wall adapter, a USB port, or are we going to be powering off of a line or an upstream power supply? So we're going to get into a little bit of discussion about these topics as well. But starting off with the input voltage, Jamil, can you tell us a little bit about the voltage characteristics of the Spartan FPGA?
Yeah, sure. Well, the basic FPGAs nowadays require about 3 rails, right? So the 3 rails, the first one is VCC int, and that's the internal or core voltage. And for Spartan3A, this is listed at 1.2 volts. The next voltage that needs to be considered is the VCC aux, and this is the auxiliary voltage, and this is used for powering up like the JTAG circuitry or like the DCM circuits. And Spartan3A has this listed at 2.5 or 3.3 volts. The next one is the VCCO, and that's the I/O voltage. And this could be one or a number of voltages, depending on the application, and it ranges from 1.2 all the way to 3.3 volts. So a number of the extended Spartan3A family users can get by with only 2 rails by combining VCC aux with VCCO. And this is really helpful for creating like a simple, low-cost design, as opposed to having to create a system for something like 4 power rails like that. But remember, anytime you can lower the voltage, you can save some power. So you do have the option to go to 3 rails and try and lower the voltage on VCC aux or VCCO to get the least power consumption.
Now that seems like a great idea. So the FPGA only needs 2 voltages. That's the core and the I/O, basically.
Well, you can combine it needs 3 voltages, VCC aux and I/O, but you can combine those on a single rail because of the ranges that it allows for.
That's pretty good, because that'll save a power supply part, really, in some board space. Now, Brian, when you were choosing the peripheral components for the development board, can you explain how that impacted your choice of components?
Yes. Well, as Jamil said, Spartan3A does have the option for making very simple, very low-cost designs if you're willing to combine the VCC aux and VCCO rails. That's definitely what we wanted to do. So we purposely selected all of our peripherals and memories to be 3.3 volt supplied, and then we also set VCC aux to be 3.3 volts. So we had our 3.3 volt supply that was providing both VCC aux and the I/O voltage to all of the banks on our FPGA. Then, of course, we also had the core voltage, VCC int, which we set to 1.2 volts. By doing this, it allowed us to have the simplest and lowest cost power supply design, the fewest number of layers in our PCB, all of these things hopefully guiding us to the point where we had the lowest possible cost board.
Thanks, Brian. Actually, designing a 1.2 volt and a 3.3 volt power supply for that whole FPGA board is a very good idea from a power supply standpoint. It saves cost, it saves board space, and it saves a lot of time in the power supply. And also, it actually goes with the concept of the whole Spartan3A idea of making the evaluation module. So the next thing we're going to talk about is where the power comes from, whether it can be from the USB port or a 5-volt wall adapter.